Hello friends, myself is Lalit Sharma. Today again I will continue the topic binary operations. Till now I have illustrated what do you mean by binary operation, what are the properties which are satisfied with respect to binary operations such as associativity, commutativity, existence of identity element. Now today I am going to explain the concept of existence of inverse element, that is which are the elements in a set which are invertible with respect to the given binary operation. This is very important and this definition is actually based on the definition of identity. So let me explain the definition of invertible elements. Let A be any non-empty set. Let A be any non-empty set and star be a binary operation on A. Let A be any non-empty set and star be a binary operation on A. Let A belongs to A be any arbitrary element. Let A belongs to A be any arbitrary element. We say B belongs to A is the inverse of A if and only if A star B is equal to E is equal to B star A. Okay. What is my condition for invertibility? That any element A belongs to A is said to be invertible if there is an element B. But what is the important point? That B should again belongs to the set A, such that what is the condition? A star B is equal to E is equal to B star A. In this case we say B is the inverse of A and denoted by B is equal to A inverse and denoted by B is equal to A inverse. Now the definition which I have told you, I am going to explain it with the help of various examples. First example, I will take it as the set of real numbers and star is usual addition on real numbers. Now my first example, let A is equal to R, that is the set of reals, and consider star as usual addition. We know that this addition is a well-defined binary operation on the set of real numbers. Now also we know that with respect to this binary operation, 0 is the identity element. Recall, any A added to 0 will again give rise to A, which is same as 0 plus A, and this property is true for each real number A belongs to R. So therefore we say 0 is the identity element, because when we proceed to find out inverse of an element, we make sure identity should exist, because if identity does not exist, then the definition of inverse is irrelevant. So before going to find the invertible elements, firstly we will check whether the identity exists or not. Okay, so in this case 0 is the additive identity, that is the identity element with respect to addition. Now my task is to find the inverse of any real number A in general. So you say for invertibility, we must have A star B equal to E equal to B star A. This is the condition of invertibility. Now again, since the operation is commutative in this case. Why? Because we know that A plus B is same as B plus A. So therefore, if we consider only one side identity, then it will be more than sufficient. So consider A star B equals to E. Now, in view of the definition of the binary operation, we must have A plus B is equal to 0. Okay, because my star is usual addition and my identity is 0. So this would implies the choice for B is minus A. This would implies the choice for B is minus A. And we know that if A is a real number, then minus A is also a real number. So I can say that this would again belongs to R. So therefore, what I have observed that for any A belongs to R, I have found one minus A in R only, which will satisfy this property. Just see this. Therefore, can I say corresponding to any A, there is an invertible element in R, namely minus A. किसी भी A का additive inverse क्या होगा? Minus A. जैसे कि 1 का additive inverse -1, 2 का -2, 3 का -3 and so on. So therefore, what we observed in the last, what is my conclusion? That with respect to addition in real numbers, invertible elements exist, and for any A belongs to R, the required inverse is negative of A. Okay. Now, on the same set, if I change my binary operation, let us take on reals star to be usual multiplication. I am taking this star to be usual multiplication of real numbers. We know that multiplication of real numbers is also a well-defined binary operation on R. So therefore, we can talk of identity element and invertible element. Also, I know that one important point, that any real number multiplied with 1 will give rise to the same real number, and which is true for 1 into A also, and this property holds for every A belongs to R. Now, if you look at the definition of identity, what was the definition of identity? A star E should be equal to A should be equal to E star A. Here star is multiplication, so AE should be equal to A should be equal to EA. So can I take E equal to 1 in view of this? So therefore, I observe that E equal to 1, which belongs to R, is the identity element. So clearly the identity element exists with respect to multiplication. So I can find inverse of a real number. So let us see whether the all elements would have inverse or there is some problem. So if we take any real number A, for invertibility, what is my condition? A star B should be equal to E should be equal to B star A. Okay. Now, again, the operation is commutative, so therefore we consider only one side, that is A star B equal to E. Now, what is my star? Star is multiplication, so it should be A into B equal to 1. Therefore, the choice for B comes out to be 1 by A. Now, I have to make sure that for any real number A, 1 by A should again belongs to R. But I observe that this element will belongs to R if A is not equal to 0. This point is very, very important, because if A happens to be 0, then what is the choice for B? It is 1 upon 0. And as far as this mathematics laws are concerned, 1 by 0 is indeterminate. Indeterminate means the value is not finite. It approaches to infinity. So therefore, what we observe finally, ki if A is a non-zero real number, then each element is invertible with inverse as 1 by A, which again belongs to R. But 0 is the only element which is not invertible. So what you finally conclude? We finally conclude that with respect to multiplication, all non-zero real numbers, say A, are invertible with inverse as 1 by A. This is my final conclusion, that if we take any non-zero real number with respect to multiplication, then that is invertible and the inverse is given by 1 upon A. So therefore, you have to be very careful that 0 is one real number which is not invertible with respect to multiplication, whereas if we are considering addition, then it is invertible, because 0 plus 0 is 0, so there is no problem. Okay. Now again, I have in the definition, I have pointed out one thing. If you remember, when I was defining inverse of an element, I have pointed out that the inverse B with again a member of A. Inverse B should be again a member of A. दोबारा A में ही belong करना चाहिए B. So I will justify this, that why this is important. If we consider in my next example, if we consider the set of non-zero integers, okay, so my A is non-zero integers, I am denoting by Z star. Z star क्या है? The set of non-zero integers, okay. My Z star denotes all non-zero integers, and I will take my star as usual multiplication. Then clearly, if we multiply two non-zero integers, the resultant is again a unique non-zero integer. So therefore, this star is a defined binary operation on the given set Z star. Again, my aim is to find invertible elements. So firstly, I make sure identity should exist. So I observe that my observation is any non-zero integer multiplied with 1 will give rise to the same integer. And this is true for 1 into A also, and also 1 belongs to Z star, and also 1 belongs to Z star. 1 एक non-zero integer है, तो कहां belong करेगा? Z star में. So this satisfies the property of identity. So can I say 1 is the identity element? So E की choice क्या है बेटा? It is equal to 1. Now I can proceed to find the invertible element. Now again, what is the definition for invertible element? A star B should be equal to E should be equal to B star A. This is my definition. For any A, I have to search a B which will satisfy this property. Now again, the operation is commutative because A into B is equal to B into A on non-zero integer. So only one side containment will prove the result, because if A star B is equal to E, then B star A has to be E because of the commutativity. So now consider A star B equal to E. What is A star B equal to E give rise to? A dot B equal to 1. Now this would implies the choice for B is 1 by A. Now clearly, because A belongs to Z star and Z star contains all non-zero integers, so one thing is pretty sure that A cannot take value 0. So therefore 1 by A is a well-defined term. But I have to make sure that it should again belongs to Z star. ये कहां belong करना चाहिए? Z star में. पर मैं कहता हूं कि ये Z star में belong ही नहीं करता अगर A की choice plus minus 1 के अलावा कुछ भी और हो तो. अगर A जो है प्लस माइनस 1 ना हो तो ये एलिमेंट कभी भी Z स्टार में आएगा ही नहीं. What I am saying is, if I take A equal to 2, clearly 2 एक नॉन जीरो इंटीजर है. If I consider 1 by A, it will be 1 by 2. 1 by 2 does not belongs to Z star. क्यों? क्योंकि 1 by 2 एक रैशनल नंबर है, नॉन जीरो इंटीजर नहीं है. सिमिलरली इफ यू टेक 3, then 1 by 3 is the inverse in view of this definition, but again 1 by 3 does not belongs to Z star. So this is how we observe. So final conclusion क्या है मेरा कि 1 by A एक्चुअली में नॉन जीरो इंटीजर होगा किन वैल्यूज के लिए? तो केवल ये दो वैल्यूज हैं, A equal to 1 and A equal to minus 1, which makes this quantity a non-zero integer. So therefore, what is my final conclusion? My final conclusion is कि there are only two elements invertible with respect to multiplication. non-zero integers में केवल दो एलिमेंट का इनवर्स एग्जिस्ट करेगा, एक 1 का और एक -1 का. इसके अलावा किसी का इनवर्स एग्जिस्ट नहीं करेगा. 1 का इनवर्स होगा 1 और -1 का इनवर्स होगा -1. Why? Because 1 dot 1 is equal to 1 and -1 dot -1 is again going to be 1. So therefore the choice for B is 1 in this case, the choice for B is -1 in this case, and both belongs to non-zero integers. So what is my final conclusion in this example? This is very important example. So what we finally conclude? I finally conclude in Z star with respect to multiplication only plus minus 1 are invertible elements. That is, other than plus minus 1, if I take any non-zero integer, then inverse would not exist within Z star. Inverse exists तो कर रहा है, but it is outside the set. And the property of inverse of an element is relevant only when you get inverse within the set. So that's why I have pointed out that the B should belongs to A. So I have justified that the important point is B belongs to A. Set में ही मिलना चाहिए, otherwise inverse की कोई value नहीं होगी. Okay, fine. So let us move further with some new examples. I hope now the definition of invertibility is quite clear to you. Although the examples which I have told you won't be asked in your board exam because they are very elementary examples. But this is how we can start this topic. Because if you got through the concept of such examples, that if A is 0, then what will happen? And if 1 by A we are taking, we make sure that 1 by A belongs to integers only for the values plus minus 1. So now we are in a position to take take some typical example. So next example, which is very, very important from board point of view. The example says, most important example hai, the example says on the set of q deleted minus 1, on the set of q deleted minus 1. That means I am considering all rational numbers except minus 1. Define a binary operation star. Define a binary operation star as a star b is equal to a plus b plus ab. Okay. What is my binary operation? A star b equals to a plus b plus ab. Clearly, sum of two rational number is again a rational number. Product of two rational number is again a rational number. So by this algebra, I can declare that this resultant element again belongs to q deleted minus 1. So therefore, one thing is sure that this is a well-defined binary operation. My task is to find the identity and inverse. Okay, my task is to find the identity and inverse, because before finding out inverse, I have to find identity. Because identity is there, only then we can talk of inverse of an element. So firstly, I will show the identity exists. In fact, in my last lecture, I have already shown that identity exists in this case, but quickly I will recall that. Okay, what is my requirement for identity element? A star E should be equal to A, should be equal to E star A for every A belongs to q deleted minus 1. Okay, and this operation is commutative also. Why? Because A plus B is same as B plus A and AB is same as BA. So I need to consider only one side identity. So what is A star E according to this definition? It will be A plus E plus AE. What should be my RHS? It should be equal to A. Now I can cancel out A on both sides. If I take E common, I'll get 1 plus A, that is equal to 0. Now whenever product of two numbers is 0, one of them has to be 0. तो या तो E 0 होगा या 1 plus A 0 होगा. तो आप लिखेंगे either E 0 or 1 plus A is 0. Now 1 plus A equal to 0 will implies A equal to minus 1, which is not true. Why it is not true? Because A belongs to q deleted minus 1. A cannot be minus 1. A is a A is a rational number which cannot be equal to minus 1. So therefore, the choice for E must be 0. So therefore, the choice for E must be 0. So we have obtained the identity element. Now I will proceed to find the inverse of an element in q deleted minus 1 with respect to the given binary operation. Now again, for invertibility, we must have A star B equal to E equal to B star A. Again, because of commutativity, I will consider only this side. Now, what is my A star B? A star B is A plus B plus AB. And what is E? E is given as 0 because I have proved it. Now, this would implies B plus AB equal to minus A. I have shifted A on the right hand side. Now, can I take B common? So, it will be 1 plus A is equal to minus A. And this would implies further that the choice for B is minus A upon 1 plus A. Now, this number minus A upon 1 plus A is meaningful if the denominator 1 plus A is non-zero. And it is evident that 1 plus A is non-zero because 1 plus A equal to 0 would implies A equal to minus 1, and that is not true. Okay? So therefore, I am sure that this element again belongs to q deleted minus 1. Now, why this element belongs to q deleted minus 1? देखो q में तो ये है, ठीक है, because this is rational, तो q में तो ये है. I have to make sure कि ये वैल्यू माइनस 1 नहीं हो सकती, क्योंकि b भी कहां होना चाहिए था बेटा? q डिलीटेड माइनस 1 में होना चाहिए था. यानी b कोई भी रैशनल नंबर हो सकता है एक्सेप्ट माइनस 1. तो अगर b माइनस 1 हो जाए तो क्या प्रॉब्लम है? प्रॉब्लम है. अगर माइनस a अपॉन 1 प्लस a इक्वल टू माइनस 1 हो जाए तो देयर मस्ट बी सम प्रॉब्लम. व्हाट इज द प्रॉब्लम? माइनस a शुड बी इक्वल टू माइनस 1 माइनस a. Now I can cancel minus a on both sides. So this will imply 0 equal to minus 1, which is a mathematical contradiction because 0 cannot be equal to minus 1. So therefore I have proved the fact that b can take any rational value except minus 1. So therefore b kahan belong karega? Q deleted minus 1 mein. So therefore I have shown फाइनली क्या है कंक्लूजन मेरा, एक तो E इक्वल टू 0 है बेटा इस केस में, ये मेरी पहली ऑब्जर्वेशन है, और दूसरी ऑब्जर्वेशन है कि फॉर एनी A द इनवर्स इज माइनस A अपॉन 1 प्लस A. दिस क्वेश्चन इज वेरी वेरी इंपॉर्टेंट क्वेश्चन फ्रॉम योर बोर्ड्स पॉइंट ऑफ व्यू. तो आपको ये समझ में आना चाहिए कि यहां पर क्या हो रहा है. नाउ वी हैव कंसीडर्ड सो मेनी एग्जांपल्स ऑन नंबर सिस्टम. Now I am proceeding towards the set of matrices. Okay, now I am taking my discussion towards the set of matrices, because we have already defined some standard binary operations on the set of matrices also. We have seen the associative property, we have seen that commutativity may not hold with respect to multiplication. Then now we'll talk of identity, and once identity is available, then I'll proceed to find the inverse of a given element. So let us consider a new example. देखिए मैथमेटिक्स के अंदर, because जब तक मैं आपको एग्जाम्पल लिख के नहीं कराऊंगा, you won't be able to understand, because when you see on the screen all the calculation, then only you will analyze. तो मेरे लिए बोलने के लिए बहुत ज्यादा नहीं है, मेरे लिए लिखने के लिए बहुत ज्यादा है, because I'll do more and more examples and the unsolved questions so that you get concept clarity and the material should be ready to you for your board exam. Okay, so now let us take a new set. What is that set beta? The set is denoted by capital M, and this set is all matrices of the type A, B, C, D, where A, B, C, D are simply real numbers. What is my set? My set is all 2 cross 2 real matrices. Now, if I take star as usual addition of matrices, usual addition of matrices, you know that what is the requirement फॉर एडिशन ऑफ टू मैट्रिसेस. दो मैट्रिसेस को आप ऐड कब कर सकते हैं? जब वो सेम ऑर्डर की हो. दो मैट्रिसेस को ऐड तभी किया जा सकता है जब वो सेम ऑर्डर की हो. और कैसे ऐड करते हैं? वी ऐड द कॉरेस्पॉन्डिंग एलिमेंट. कॉरेस्पॉन्डिंग एलिमेंट्स मींस यहां का एलिमेंट यहां के फर्स्ट एलिमेंट से ऐड होगा. अगर यहां पे एक और मैट्रिक्स है, सपोज A डैश, B डैश, C डैश, D डैश, देन हाउ विल ऐड? A प्लस A डैश, B plus B dash, C plus C dash, and D plus D dash. This is called coordinate wise, component wise addition. Okay, so this is how addition take place in the set of matrices. So this is a well defined binary operation. Why? Because sum of two real number is again a real number. So when you add these two matrices, you will again get a 2 cross 2 real matrix. So therefore this is a well defined binary operation. He says find the identity element and invertible elements. So obviously in my last lecture I have explained about identity. I have shown that any matrix A, B, C, D added to 0, 0, 0, 0 will again give rise to the same matrix A, B, C, D, will again give rise to the same matrix A, B, C, D. Why? Because A plus 0 is same as A, B plus 0 is same as B, C plus 0 is same as C, and D plus 0 is same as D. So therefore what I have observed, and this is again a member of M. This is again a member of M. Why it's a member of M? Because what is the requirement for any matrix to be in M? It should be a 2 cross 2 matrix और सारी एंट्रीज रियल नंबर होनी चाहिए. एंट्रीज सेम हो, डिस्टिंक्ट हो, देयर इज नो कंपल्शन, बट द एंट्रीज मस्ट बी रियल नंबर्स. तो व्हाट आई हैव ऑब्जर्व्ड, 0 इज अ रियल नंबर. सो ऑब्वियसली ये मैट्रिक्स 0, 0, 0, 0 कहां बिलोंग करेगी? एम में बिलोंग करेगी. सो देयरफॉर व्हाट आई हैव ऑब्जर्व्ड फाइनली, दैट 0, 0, 0, 0 दैट इज अ 2 cross 2 null matrix serves as the identity element. So what is my identity element in this case? The identity element is 0, 0, 0, 0 which belongs to M. This is my first conclusion. Now I want to comment on invertible element. So what is my condition for invertible element? For invertible element I must have कि किसी भी ABCD में, अब इनवर्स जो होता है आप जानते हैं वो उसी सेट में बिलोंग करता है, तो जो इनवर्स होगा वो भी M में बिलोंग करेगा. एंड इफ एनीथिंग बिलोंग्स टू M, इट मस्ट बी अ 2 cross 2 रियल मैट्रिक्स. सो व्हाट इज द चॉइस फॉर B? लेट इट बी A dash, B dash, C dash, D dash. Okay, and this should be equal to the identity element, that is 0, 0, 0, 0, because again the operation is commutative, so only this side containment will work. The possible proof, now this will be equal to A plus A dash, B plus B dash, C plus C dash, and D plus D dash. This must be equal to 0, 0, 0, 0. Now when two matrices are equal, when they have same order and the corresponding elements are equal, both matrices will have order 2. So therefore there is no problem with order. Now the equality must be there if we have A plus A dash 0, B plus B dash 0, C plus C dash 0 and D plus D dash 0. So what is the choice for A dash, B dash, C dash, D dash? A dash must be equal to minus A, B dash must be equal to minus B, C dash must be equal to minus C, and D dash must be equal to minus D. So finally, what is my inverse? For any A, B, C, D, the required inverse is minus A, minus B, minus C, minus D. And we know that if A is a real number, minus A is also a real number. So therefore, by that argument, I can say that yes, this inverse will again belongs to M. So therefore, I have found out the inverse of any square matrix of order 2 A, B, C, D where entries are real as minus A, minus B, minus C, minus D. So this is my first example. Now, I have also told you about usual matrix multiplication as binary operation. So again on M, same M which I have defined in the previous example, let us take star as usual matrix multiplication. I have taken my star as usual matrix multiplication. We know that two matrices can be multiplied if the number of columns of first matrix should be equal to number of rows of second matrix. आप दो matrices को कभी भी multiply नहीं कर सकते. There must be a condition which we need to satisfy first. Only then we can multiply two matrices. क्या condition है? पहली matrix के columns, the number of columns of first matrix must coincides with number of rows of second matrix. Now here both matrices have order 2 cross 2. दोनों का ही order 2 cross 2 है. So obviously number of columns is equal to number of rows. No, कोई प्रॉब्लम नहीं है. So we can always multiply two matrices. और आपको ये भी पता है कि अगर आप दो matrices को multiply करो तो जो resultant order होता है वो क्या होता है? This cross this. This is again 2 cross 2. तो जब आप multiply करेंगे इन दो matrices को तो दोबारा आपको एक 2 cross 2 real matrix ही मिलेगी, because some product of real number is again a real number. तो ये एक well defined binary operation है. Now again the question arises, find the identity element and invertible elements. Now the important point is, if we talk of identity element, then we know that this I, which is 1 0 0 1, that is on the diagonal places I have 1, else is 0. Clearly it's a 2 cross 2 real matrix. तो ये M में belong करेगी क्योंकि ये 2 cross 2 real matrix है. इसका order 2 cross 2 है और ये जो entries है 1 0 0 1 ये real numbers है. अब अगर मैं ये claim कर रहा हूं कि ये identity है तो इसको क्या property satisfy करनी पड़ेगी? A into I must be equal to A must be equal to I into A. Okay, and this fact is well known from matrices, because from matrices we know that A into I is always equal to A is always equal to I into A. If you want to verify, you can verify also. You can take any A as A, B, C, D. Okay, and now you can multiply A with I. If you multiply A with I, it will be this with this. So see the resultant. What will be the resultant? How we multiply two matrices? First row should be multiplied with each column. So it will be A into 1 plus B into 0. So resultant would be A. Now this matrix, now this row will be multiplied with this column. A into 0 plus B into 1. Similarly, C into 1 plus D into 0. Now C into 0 plus D into 1. So what I observe, that AI is same as A, which is equal to ABCD. Similarly, you can prove that IA is also A. So therefore, what I observed that my E is the identity matrix which actually belongs to M. Okay, fine. So identity तो मिल गई. अब मुझे inverse की बात करनी है. That means I need to find inverse of A. अगर inverse of A exist करेगा तो उसको ये property satisfy करनी पड़ेगी. ठीक है कि नहीं है बेटा? A into A inverse must be equal to identity must be equal to A inverse into A. अब एक बड़ी इंपॉर्टेंट बात है कि क्या हम किसी भी मैट्रिक्स का इनवर्स निकाल सकते हैं? कैन वी फाइंड इनवर्स ऑफ एनी आर्बिट्री मैट्रिक्स, और देयर मस्ट बी अ कंडीशन व्हिच वी नीड टू चेक फर्स्ट, ओनली देन वी शैल प्रोसीड टू फाइंड द इनवर्स ऑफ अ मैट्रिक्स. अगेन द कंडीशन हैज टू बी देयर, एंड व्हाट इज द कंडीशन? द कंडीशन ऑफ नॉन सिंगुलैरिटी. वी से नोट a matrix, obviously square matrix, ठीक है? A matrix is invertible, a matrix say A is invertible if and only if determinant A is not equal to 0. This is the condition. I hope you remember that कि किसी भी मैट्रिक्स का इनवर्स कब निकलता है? जब उसका डिटर्मिनेंट नॉन जीरो हो. और यहां पर अगर हम मैट्रिक्स कंसीडर कर लें से 6 into 4 12 2, सपोज मैं ये मैट्रिक्स कंसीडर कर लूं A, क्लियरली ये m में तो बिलोंग कर रही है और ये m में बिलोंग कर रही है और इसका डिटर्मिनेंट क्या है 24 माइनस 24 विच इज इक्वल टू 0, तो इसका इनवर्स एग्जिस्ट करेगा ही नहीं. सो देयरफॉर ऑल द मैट्रिसेस which have determinant value equal to 0 are not invertible. इसका मतलब है कि कौन सी मैट्रिक्स हुई जो इन्वर्टिबल है, जिनका डिटर्मिनेंट नॉन जीरो होगा. सो देयरफॉर व्हाट इज माय कंक्लूजन कि इन m with respect to star only such ABCD matrices यानी such matrices are invertible which satisfies AD minus BC not equal to 0, because you know that for this matrix what is the determinant value, it should be AD minus BC. तो ये बड़ी इंपॉर्टेंट ऑब्जर्वेशन है कि जब एडिशन के साथ लिया तो कोई प्रॉब्लम नहीं हुई, सभी एलिमेंट का इनवर्स मिल गया. बट व्हेन वी कंसीडर विद रिस्पेक्ट टू मल्टीप्लिकेशन वी हैव टू बी वेरी केयरफुल दैट वी हैव टू कंसीडर ओनली दोज मैट्रिसेस व्हिच हैव डिटर्मिनेंट वैल्यू नॉट इक्वल टू 0, बिकॉज ओनली दे विल सेटिस्फाइज द क्लास ऑफ इन्वर्टिबल मैट्रिसेस. सो एक बहुत इंपॉर्टेंट रिमार्क ये हो गया कि जब भी आप नॉन सिंगुलर मैट्रिसेस को कंसीडर करेंगे तभी वो इन्वर्टिबिलिटी की कंडीशन सेटिस्फाई करेगी. अगर आपने कोई भी मैट्रिक्स ली जो सिंगुलर है वो इस कंडीशन को इन्वर्टिबिलिटी की सेटिस्फाई नहीं करेगी. ओके, आई हैव गिवन यू द एग्जांपल. और इसका रीजन क्या होता है? इसका रीजन ये होता है कि वी डिफाइन ए इनवर्स एज एडजॉइंट ए अपॉन डिटर्मिनेंट ए. दिस इज द फॉर्मूला टू कैलकुलेट इनवर्स ऑफ अ मैट्रिक्स. सो ऑब्वियसली बोथ आर numbers, and in numbers we know that a by b is meaningful only when b is not equal to 0, क्योंकि अगर b 0 हो गया बेटा तो ये चीज इंफिनिटी को टेंड कर जाएगी, इनडिटर्मिनेंट हो जाएगी, अनडिफाइंड हो जाएगी. देयरफॉर आई टेक डिटर्मिनेंट वैल्यू टू बी नॉन जीरो. ये रीजन है, बिकॉज ऑफ द फॉर्मूला a इनवर्स इज इक्वल टू एडजॉइंट ए अपॉन डिटर्मिनेंट ए, वी मेक श्योर. नाउ फर्दर अब हमने अभी तो एक चीज पढ़ी कि भाई जो मैट्रिसेस नॉन जीरो होती, नॉन सिंगुलर होती हैं वही इन्वर्टिबल होती हैं. बट नाउ आई विल गिव यू वन एग्जांपल विच विल एक्चुअली क्लियर द पिक्चर. ओके, आई विल शो अ मैट्रिक्स whose determinant value is 0 but yet it is invertible, and I will explain the reason that why it is happening. Okay, why it is happening. So now I'm going to consider very very important example. इस example की explanation किसी भी किताब में नहीं है, सभी किताब में ज्यादातर ये क्वेश्चन इनकॉर्पोरेट हो गया है. अब इन आर डी शर्मा, इन आरपी सिंह, इन आर एस अग्रवाल में भी द क्वेश्चन इज देयर बट द करेक्ट एक्सप्लेनेशन is not available. So I am going to give you the correct explanation for the reason of invertibility with determinant value even 0. Okay, so what is the example? The example